How many digits are there in 125 to the 20th power? To determine the number of digits, we are going to use the logarithmic approach. The idea in logarithmic approach is to find the logarithm of this power to base 10, and that will tell us the number of digits in the number. Hi there, and welcome to my YouTube channel. Today's math tutorial promises to be another exciting one. But if you're yet to subscribe to my channel, please go ahead, subscribe now, click on the notification bell so that you get updated from time to time from this channel. Now, in finding the number of digits in this power, we are going to start with a familiar number in order to prove the validity of the method or the approach that we want to take. So let us consider 500, which we know as 3 digits. And let us say k is equal to 500. Then the logarithm of k to base 10 is 2.699. That simply means that k is approximately 10 to the power of 2.699. Don't forget that the logarithm of 100 has 2 in the integer part because it is 10 to the power of 2. However, the logarithm of 500 is greater than 10 to the power of 2 but less than 10 to the power of 3. So that means it is in between. And therefore, k should have 3 digits, as 10 to the power of 2 has 3 digits. So applying this approach, we'll let m be the power in consideration, 125 to the 20th power. Then we take the logarithm of both sides. So the logarithm of m is equal to the logarithm of 125 to the 20th power. This is the same thing as 20 times the logarithm of 125, which is further written as 20 times the logarithm of 1.25 times 10 to the second power in standard form. This further can be written as 20 times the logarithm of 1.25 plus the logarithm of 10 to the power of 2. The logarithm of 10 to the power of 2 is 2. So we have 20 times, I'll be writing that logarithm of 10 to the power of 2. I'll be writing the 2 first, so 2 plus the logarithm of 1.25. And the logarithm of 1.25 is 0.0969. So we have 20 times the sum of 2 and 0.0969. That's the product of 20 and 2.0969, which is 41.938. So that means m is actually the antilog of the decimal part, that's 0.938 times 10 to the power of the integer part, 10 to the power of 41. The antilog of 0.939, the decimal part, actually has 1 digit. It has 1 digit in the before the decimal point. While 10 to the power of 41 has 41 zeros. What this simply means is that there are 42 digits in total. And the conclusion is that 125 to the power of 20 has 42 digits using the logarithm approach. Now, a quick one for you. How many digits has 86 to the power of 15? let me know in the comment section. You can also post your questions, suggestions into the comment section, or you send them to the email attached to the description of this video. Please don't forget to like this video, share it, and if you're yet to subscribe, here's another opportunity. Please click on the subscribe button and the notification bell. And as I look up to you watching my next video, have a lovely day. Bye.